Welcome to a Sim Code. Hi everyone. Make sure to like and subscribe if you want to see more exciting content. A graph is a nonlinear data structure used to represent relationships between objects. It consists of vertices, also called nodes, and edges, connections between nodes. Graphs are commonly used to model networks, like social media connections, road maps, or web pages. Let's dive into graphs, a crucial concept in computer science. In this video, we will be implementing a simple graph using an adjacency matrix. First, let's define the structure of the graph and its essential functions. Max number of vertices in our graph. We set it to 10 for simplicity. This limits the graph size. This is the adjacency matrix. It represents the edges of the graph. This keeps track of the number of vertices in the graph. A graph consists of vertices, nodes, and edges, connections between nodes. Here, we are using an adjacency matrix to represent the graph. Why we use an adjacency matrix, efficient for dense graphs where the number of edges is close to the maximum possible, v squared. Allows for quick lookup of whether an edge exists between two vertices in constant time. We initialize all the values in the adjacency matrix to 0. This means no edges exist initially. Initially, all edges are absent. No vertices have been added yet. The initGraph function is used to initialize an empty graph. It sets all elements of the adjacency matrix to 0, indicating no edges. The number of vertices is initially set to 0, indicating the graph is empty. Increment the number of vertices in the graph. The addVertex function is used to add a vertex to the graph. We first check if the number of vertices has reached the maximum limit max_vertices. If we can add more vertices, we increase number of vertices and print a message. Otherwise, we display an error message indicating the limit is reached. Check if the vertices are valid. We cannot add edges between invalid vertices. Mark the edge from U to V. Mark the edge from V to U, since it's undirected. The addEdge function adds an undirected edge between two vertices U and V. We first ensure that both U and V are valid vertices, for example, within the range of 0 to number vertices, 1. Print 1 if there is an edge, 0 if there is not. The display graph function prints the adjacency matrix of the graph to the console. This matrix visually represents the structure of the graph, showing where edges exist. We loop through the ADJ matrix and print 1 where there is an edge, and 0 where there is no edge. First, we mark the current vertex as visited. One means visited, 0 means not visited. Now, we visit all the adjacent vertices that have not been visited yet. If there is an edge from the current vertex to I, and I has not been visited yet, we call DFS recursively. The DFS function is a recursive implementation of depth-first search, DFS. DFS is an algorithm to traverse all vertices of a graph. It explores as deep as possible along each branch before backtracking. The visited array keeps track of whether a vertex has been visited to avoid revisiting the same vertex. For every vertex, we recursively call DFS on its unvisited neighbors, vertices connected via edges. We use this array to track visited vertices. Initially, all vertices are unvisited, 0. Start the DFS traversal from the given vertex. The startDFS function initializes the visited array to keep track of whether each vertex has been visited during DFS. It sets all elements of visited to 0, meaning no vertices have been visited yet. Then it calls the DFS function, starting the depth-first traversal from the start vertex. Declare a graph object. Initialize the graph. Let's add some vertices to our graph. Add vertex 0. Add vertex 1. Add vertex 2. Now, let's add some edges to connect the vertices. Edge between vertex 0 and vertex 1. Edge between vertex 1 and vertex 2. Display the current graph structure. Perform a DFS traversal starting from vertex 0. Now run our code. Thanks for being here. Don't forget to like, comment, and subscribe.